remember that we discussed current division and voltage division methods. So I clearly explained that the networks can be classified into two categories. The first category is the single energy source networks. Okay. And the second one is multi-energy source networks. All single energy source networks can be easily solved by current division or voltage division method. And how we solve it, we already discussed by taking an example of the same network we have seen. Okay. And we calculated current through each and every element using current division, and we calculated voltage across each and every element, okay, using voltage division method. And we can also conclude at this stage that in the current division method, we find current first, then voltage and power next. And in the case of voltage division method, we find voltage first, then current and power next. Okay. So this is a simple procedure, and to make you understand, I have done systematically step-by-step procedure how to create two series elements to divide the voltage in case of voltage division, how to create two parallel elements, okay, to apply current division method in case of current division method, right? These are all we discussed clearly. Now, let us look at an alternative approach when single energy source network is given, and when you are able to reduce the network using simple series and parallel combination without going for star delta transformation. Okay, for example, if you take this network, to find the input resistance, I think you don't need to apply star delta for this kind of network. Okay, so for single energy source networks, where the input resistance can be determined without applying star delta transformation, okay, you can apply a very simple method, okay, very simple technique, even without applying this current division and voltage division methods. Okay, you have a simple method. The simple method name I will tell you later after solving this particular problem. I put the title of that method after solving, okay, after explaining that particular method here. Okay, and remember, the disadvantage with the current division, voltage division is what actually here we have seen last class. We need to always reduce the network. Yes or no? To create the parallel elements. The parallel elements are not available directly in the case of current division method. We have to create two parallel elements. That means you have to reduce the network, okay, to that extent where you require an element, okay, two parallel elements to create the parallel elements. Similarly, in the case of voltage division method. So without applying any reduction, without applying current division, voltage division formulas, we can take this network as it is, just directly attack the network to find current voltage everywhere in the network. You understand all of you? Okay. So look at this first. Don't write. Concentrate here. I'm going to explain you this method. Before I explain that method, okay, first let me take a simple example which we know very well. Say this is 10 volt. This is 2 ohm. This is 3 ohm. Okay. Now, what could be the voltage across 2 ohm and across 3 ohm? What is the voltage across 2 ohm? What is the voltage across 3 ohm? How do you find voltage division? Simply, you can apply. Now, 2 by 2 plus 3 into 10 will give you what? 4 volt. 10 minus 4, what do you get here? 6 volt. Yes or no? This is what the voltage that you get here. Okay. Now, let me explain the same thing. I know that the voltage across 2 ohm is 4 volt. Voltage across 3 ohm is 6 volt. I know the answer, no doubt. But let me get this answer in a different interpretation, with a different interpretation. Look at this. Look at this. If I take this particular point or node as zero potential, okay, because I think we have explained when we have taken classification of energy sources topic, in that we have explained clearly the potential difference between these 2 points is 10. If this is taken 0, then what is it going to be here? This node is operating at what? 10 volts. Agree? Yes. Now, if I know the voltage at this node, is it not the voltage across 3 ohm because it is taken as 0? Yes or no? Okay. So for that, what I do is, to know this voltage, I jump from this point to this point. and jumping from higher potential to lower potential point. Hope you understand the point here, okay? I'm jumping from this point to this point, okay? Passing through what? Plus to minus. So jumping from higher potential to lower potential, then obviously there is a decrease in voltage. Higher potential to lower potential, whenever you jump, what will happen? There is a decrease in voltage. That means you drop the voltage. How much you need to drop here? 4 volts. So 10 volts, drop 4 volts. What is the remaining here? 6 volts. Since it is 6 minus 0, since 6 minus 0, the expression itself is saying that 6 minus 0, 6 is higher plus, 0 is lower minus. That's it. That is 6 volt. Clear? I know the answer. Already that 6 volt, but we can also analyze the same scenario in a different fashion with a different interpretation. Okay. Now, the same thing, let us repeat even like this also. For example, let us say these two are known and I want to find this voltage. Okay. I already know the value here. 6 plus 4 is nothing but 10, no doubt in that. But let us try to analyze, okay, in a fashion what I have explained just now. If you take this is 0, what is it going to be? This is 6 volt. Yes or no? You are taking here 0, that means 6 volt. If you take 0 here, it is minus 6 volt. Finally, the potential difference must be what? 6 volt with plus minus. That's it. Okay, but I am taking for my convenience 0, then this is 6 volt. Now to find this particular node voltage, let me jump from this point to this point. Now I am jumping from lower potential to higher potential. Then what will happen when I jump from lower potential to higher potential? Increase in voltage. Then you want to take the voltage or drop the voltage? Take the voltage. So 6 plus 4 will give you 10 volts. Since it is 10 and 0, then 10 minus 0 will give you what? 10 volts. I think all of you might have understood that how we are taking it. It is simply jumping from one node to the other node. If you know one particular node voltage, from that node to the other node where you need to find the voltage, you can easily jump. But while jumping, you must remember whether you are jumping from higher potential to lower potential or lower potential to higher potential. That's very important point here. When you jump from higher potential to lower potential, you drop the voltage. When you jump from lower potential to higher potential, you take the voltage. Clear? Now let us try to apply the same thing here for this particular big network and see how we are going to solve it without using any reduction, without using any formula, nothing. Okay, look at this. Now, for that, applying this method, you need to take one of the terminals as what? 0. Okay, that the bottom node, particularly the bottom node must be taken as 0. And you define one particular node voltage by taking 0. That is how much? 30 volts. Please encircle the value that I write here, that I am determining, whatever I am determining here, I am just encircling, leaving all other as it is, okay, as they are given. Now, I want to jump from this point to this point. If I jump from this point to this point, I need to know the voltage across what? 6 volt. To know the voltage here, I must know current. Yes or no? Because to find the voltage here, I must know current. How do you find the current here? Total current. Total current is total voltage by total resistance. You already found the resistance here. For this, you require reduction, no doubt in that. Because to find the total resistance, you require definitely the reduction method. You need to apply reduction method to find the total resistance. 5 plus 5, 4, 1 plus 4, 5, 5 parallel 24, 4 plus 2, 6, 6 parallel 12, 4, 4 plus 6, 10. That is 3 amperes. Understand? Now 3 into 6, 18 volt. What are the polarities here? Current direction will decide the polarities in the passive element. This is plus, this is minus. Yes or no? How you got it? 6 into 3. I am just writing all the details here. Now, jump from this point to this point. You are jumping from higher potential to lower potential. You drop the voltage. If you drop the voltage, what is the remaining voltage here? 12 volt. This you got 30 minus 18. I'm just writing all the details, okay? Because this is the first example, okay? Let us write everything clear. And now, let us jump from this point to this point. Just see the sequence, how you are to analyze, how you are supposed to follow the sequence. Look at this. To jump from this point to this point, you must know the voltage across 2 ohm. Yes or no? To find the voltage across 2 ohm, you must require current through 2 ohm. To find current through 2 ohm, you must require current here, because already you know the current here. How much current is flowing here? 3 amperes. If you know current here, you can find the current here. But to find the current here, you already know the voltage across 12, because this is 0, this is 12. Then the voltage across this one is 12. Therefore, 12 by 12 will give you 1 ampere. 3 minus 1, 2 ampere KCL according to 3 minus 1. I am writing all the details. 2 into 2. Definitely polarity is plus minus because of the current direction. 4 volts. Let me write once again. 2 into 2. Now jump from this point to this point again. You're jumping from higher potential to lower potential. You drop the voltage again. What is the remaining voltage? 8 volt. Let me write again details. 12 minus 4. 8 by 20, because to jump from this point to this point, you require again the voltage across 1 ohm. To find voltage, you require current here. If you want to find current here, you must know current here. What is the current flowing here? Because it is 0, this is 8, 8 minus 0. Therefore, 8 by 20, 0.4 ampere. Here, how much 2 amperes current is flowing? Then 0.4. Then what is the remaining here? 1.6 ampere. This 2 minus 0.4 ampere. 1.6 into 1 plus minus 1.6 volt. The polarities are based on the direction of current. 1.6 into 1. Jump from this point to this point. You drop the voltage. The remaining voltage is how much? 6.4 volts. 8 minus 1.6. See, I can proceed even 2 more kilometers like this. Just jumping from one point to other point easily without any reduction. Just by jumping from one point to other, I call this method as jumping technique. Jumping technique. So I very frequently use this word jumping technique. Use the jumping technique simply in solving the networks. Okay, that means you must follow this particular procedure to apply the jumping technique. I'm telling you, in node analysis, when multi-source networks are given, if you are aware of this particular technique, a 4-equation problem can be solved by 3-equation problem. A 3-equation problem can be solved by 2-equation problem. A 2-equation problem can be solved by 1-equation problem. You can save a lot of time. You can easily analyze, if you know one particular node voltage, any complex network can be easily analyzed if you are really aware of this particular technique. But I am telling you, you require a little more practice to get the command over this. For that, I am going to take some more examples here. Do not worry about it. Okay. So first, you please note down all these things. And first step, I think all of you understand. First, we need to define 0 here. Define one particular node voltage. That's it. If you know one node voltage, from that you can jump easily. To jump, what you require here to here, you need voltage. To find the voltage, you need current. First I found current, then I found voltage. Again here, jumping from this point to this point, I need voltage. For that I need current. To find current here, you already know current here, you need to find the current here. That's it. Again voltage, jump. Like this you are supposed to follow. No reduction, no current division, no voltage division. But I'm telling you, this method is applicable only for the networks of single energy source, and also the input resistance can be determined without applying star delta transformation. So if you are able to do that, then you can apply this jumping technique. For a network where star delta transformation is required to find the input resistance, this method is not applicable. Okay, please note down. Classroom workbook, question number 21. Just note down this problem. What is the question? You can read. Determine voltage source value Vs if current through 20 ohm is given 1 ampere. Yes or no? That is the question, right? So 4 ohm, 1 ohm, 20 ohm. Here it is given 1 ampere. This data is given. 2 ohm, 12 ohm and 6 ohm. Okay, this question was asked in GATE with different numericals. Okay, the same network is given, but numericals are different. Okay, so GATE. Let us find Vs having known this current through 20 ohm resistor. Remember, any network of single source can be solved by current division and voltage division methods. No doubt in that. Remember. Okay, any network of single source can be solved by what? Current division, voltage division. And of course, to apply current division, voltage division, the single source network must be like this. The input resistance should be or can be calculated without applying star delta transformation. That means what? All elements are either series or parallel. There is no such scenario you get like, certain case where elements are connected in neither series nor parallel. If you find neither series nor parallel, then again you have to go for star delta, where again this current division, voltage division do not work. There even jumping technique also does not work. Understand? Okay. So remember that. That's very important. Now let us look at that problem. Note down that quickly. Now here, what is given? Current through 20 ohm. Single source network. Just by looking at the network, you must realize that yes, this can be solved by jumping technique. How do you do that? The total resistance or input resistance can be determined easily just by using series parallel combination. That's it. Without even going for what? Star delta transformation. And a single source network. That's it. For that, you require some node voltage at one particular node. For that, he has given the current. Can you find the voltage here? What is this? 20 volts. 20 into 1. Now, take this node as 0. What could be the voltage here? 20 volt. Now, jumping from here to here and then here to here, this will give you Vs because it is already taken as what? 0. This entire one is 0. Yes or no? Jump from this point to this point. To jump from this point to this point, you need the voltage. To find the voltage here, you need the current. Look at the sequence. The sequence must be very clear. Jump from this point to this point, you need voltage. To find voltage, you need current. To find current, you need current here. What is the current flowing here? What is the voltage total? 20 by what is the total path resistance? 5. 20 by 5. How much it is? 4 ampere. 4 ampere is leaving. 1 ampere is leaving. To satisfy Kirchhoff's current law here, how much current should enter? 5 ampere. Yes, sir? Now, 5 into 2. This is plus, this is minus based on the direction of current. This direction of current is placed based on the KCL. If you place the direction like this, then only the KCL will be satisfied. Sum of the entering currents is equal to sum of the leaving currents. 5 into 2, 10 volts. 5 into 2, 10 volts. Jump from this point to this point, you are getting what? Taking the voltage, because lower potential to higher potential you are jumping. When you jump from lower to higher, you take the voltage. So 20 plus 10, 30. Again jump from this point to this point. For that you require voltage to find current. To find current, you must know current here. that is 30 by 12, 2.5 ampere. 2.5 leaving, 5 leaving, so total must be 7.5 ampere should enter. 7.5 into 6, this is 45 volts. Okay. Now jump from this point to this point, lower to higher. Take the voltage. How much it is? 75 volts. That's it. Understand all of you? 75 minus 0. It must be 75 volts. That's it. This is your answer. Okay. So before you note down, I'll give you one more important point here. Suppose instead of taking this is 0, I would like to take 10 volts. What will happen? Is it compulsory that we should take always 0? No. You can take even any other value. Take 10 volts, minus 10 volts, it doesn't matter. Suppose you take 10 volts here. 10, then it will be what? 30, not 10 again, okay? If this is 10, this is 30. Because 30 minus 10, you must get what? 20. The potential difference must be 20. For that, you can take any combination. You can take even 20 and 50, 20 and 40 combination, doesn't matter. For example, you take 10, this is 30. 10, this is 30. 30 plus 10, 40. 40 plus 45, 85. 85 minus 10, because now you are taken 10, right? 85 minus 10 will give you what? 75. So that value doesn't change. If reference node voltage, this is called reference node, generally we call it. If reference node voltage is taken other than 0, okay, do you have any problem? Not a problem. But what is more comfortable for us? 0 is comfortable. That's why we are taking 0. But it doesn't mean that you always go for 0. There is no rule as such. You take minus 10. If it is minus 10, decrease, then it should also be decreased by 10, right? So it is 10. 10 plus 10, 20. 20 plus 45. How much it is? 65. 65 minus of minus 10. 75. Hope you understand the point. This is how you can realize, you can understand or interpret, or you can solve the problems using the simple jumping technique. You can play with the networks, I'm telling you, if you practice more and more number of problems. Okay. So please take down. Meanwhile, I'll just note another problem here. Note down that. Classroom workbook, question number 22. You will understand the importance of this method in this particular example. You should also realize, looking at the network, whether this jumping technique is applicable or not. Hope you have already finished that part. Then please come back to the question number 22, which is already given in your classroom workbook. Question number 22, please note that once again in your notebook, and we'll try to solve it. If current through 9 ohm is 1 ampere, what is the source voltage Vg? That's the question, right? If current through 9 ohm is 1 ampere, what is the source voltage Vg? That's the question. That's the question, right? Okay. Hope you have noted down that problem, right? Now let us look at. First, by looking at the network itself, you must realize which method is the suitable method. You have only two types of networks. One is a single source, the other is the multi-source. It is single source. Single source networks are usually solved by current division or voltage division. For these two methods, we found an alternative approach that is called jumping technique. To apply this jumping technique or current division or voltage division, what is the rule? You must be in a position to find the resistance across the input terminals just by using the normal series and parallel combination reduction method without star data transformation. First you check how these two are connected, series, then parallel, then series, then parallel. Then that result is in series. Yes or no? Then that result is parallel. Now here you need to stop because these two are parallel again. And this resultant is in series with the one you got up to this. That result is what again parallel to this, then series. That means what's happening here? You are able to find the input resistance without star data transformation with just simple normal series parallel combination. For all such cases, you can apply jumping technique without any problem. Okay? Look at this. To get this voltage, you must require one node voltage somewhere. Further, the data is given that 9 ohm and 1 ampere is given. What is the voltage here? 9 into 1, you got 9 volts. Yes or no? If you take this one 0, definitely, otherwise there is no point or meaning, or it doesn't make any sense. Most of the people simply say that this is 9 volts, that's it, without bothering about whether it is 0 or not. But I'm telling you, without taking 0, putting it 9 volts, it doesn't make any sense. Voltage must be mentioned always between 2 points. There is no single point voltage. Okay? So, this is a voltage with respect to this, how much? 9 volt. Let's jump from this point to this point. To jump from this point to this point, you need voltage. Yes or no? To find the voltage, you require current. To find the current, you require current here. Therefore, what is this? 9 minus 0. 9 minus 0 by path resistance. 9 by 3 ampere. Okay. 3 amperes leaving, 1 ampere leaving, total 4 amperes leaving. How much should enter? 4 amperes. To satisfy Kirchhoff's current law at this node, 4 amperes is supposed to enter. 4 into 4 plus minus 16 volts. I'm not writing all the details. You can easily understand now. 9 plus 16 will give you 25 because you are jumping from lower potential to higher potential. You take the voltage. 9 plus 16, 25 volts. Now here is an important point to be observed. You need to jump from this point to this point. Okay. Actually, you have two elements, right? So better you simplify it by a single element, right? What is this? 20 and 5. They are in parallel. 20 parallel 5. This will give you 4 ohm, right? So let me take it as 4 ohm. Understand? Let me take it as 4 ohm. Is it clear, all of you? This is 4 ohm. 20 parallel 5. This is 4 ohm. Now, jump from this point to this point. Across 4 ohm, you require voltage. To find the voltage, you require current. Yes or no? To find current here, you require, look at this, how many elements are connected to this node? This. To find the current here, you must know current here. But you already know current here, yes or no? So what are the remaining two elements that you must know current through? These two, right? Now this current is known, how much? 25 by 25, by 25 minus 0. 25 minus 0 by 25, that means 25 by 25. Okay, this is, you can say, one ampere. And I must know current here. What is the expression? Would you like to take 25 by 40? No, because there is a resistor. Therefore, the voltage at this point is 0. It does not mean that the voltage here is also 0. Definitely not, because this point and this point are not operating at same potentials. There is some potential difference. Yes or no? Because there is a resistor, there is some potential difference. You need to find the voltage at this node. You cannot take it 0. You cannot take 25 minus 0 by 40 because there is an element. You can't say this is 0, therefore this is 0. It's not possible. In the previous examples, we never had a resistor in this path. Yes or no? We always have, short. That's it. Zero resistance path. But now you have a different scenario here. Look at this. Now our objective is what? Jumping from here to here. For that you require voltage. For that you require current. For that you require current here. I already know current here. I just found current here. I need to find the current here. To find the current here, I must know the voltage here. But already I know the voltage here. Can't I jump from this point to this point to know the voltage? Yes, I can. But to jump from this point to this point, again I must know voltage here. To find the voltage, I must know current here. See the sequence, how beautiful it is. You must require the current ultimately here. That is 1 ampere. How much it is? 3 ampere. How much total is entering? 5 ampere. How much should leave from this node to satisfy Kirchhoff's current law here? 5 ampere. 5 into 3 plus minus 15 volt. Jump from this point to this point, that means higher to lower. You drop the voltage. 0 minus 15, that is minus 15 volt. Now you tell me, what is the current flowing in this particular path? 25 minus of minus 15, how much it is? 40 volt. 40 by 40 will give you 40 by 40, 1 ampere. See? Now you know everything here. Current here and here. Can't you find current here now? 1 ampere, 4 ampere, 1 ampere. Total how much here? 6 ampere. Now what is the voltage here? You come to know 6 into 4, 24 volt. You understand, all of you? Now jump from this point to this point. You are jumping from lower potential to what? Lower potential to higher potential. Okay, lower potential, higher potential. Take the voltage. This is going to be 49 voltage. You take the voltage 25 plus 24, 49. Now jump from this point to this point. Okay. To jump from this point to this point, you require the voltage across it. And to find the voltage, again current. To find the current, you must know current here. 49 by 32 or 49 minus of minus 15 by 32? Definitely 49 minus of minus 15. Okay, that is 64. 64 by 32. The voltage across this one is, okay, that is 49 minus of minus 15 by 32. That is 2 ampere. 2 ampere current is flowing here. 6 ampere current is flowing here. Okay, what is the total current actually here? 8 ampere now. That should enter, leaving and leaving. 8 amperes leaving, 8 amperes should enter to satisfy KCL. 8 into 10 will give you 80 volts. Jump from this point to this point. 49 plus 80, because you are jumping from lower potential to higher potential. You should take the voltage 129 volts. Yes or no? Now, you see, 129 volts, okay, minus of minus 15 is nothing but Vg now. Yes or no? Because this is not 0 to take directly this 129. Because the other potential, the other node is operating at different potential here other than 0, that is minus 15. Potential difference will give you this. Therefore, 129 minus of minus 15, that is 144 volts. This is your answer. For explanation, it takes a lot of time. I'm explaining you, that's why it is taking a lot of time. I'm explaining you each and every point, that's why it is looking like taking time. But given a problem, if you have an idea about it, smash it within no time. You require practice. I'm telling you, you require practice. But I'm telling you, you can play with the networks if you have the idea about this particular technique. So practice as many questions as possible, single source networks you take, and you can play with the networks. I'm sure that you will definitely, become perfect in solving the networks. Please, quickly, note down. The most critical point or crucial point in this entire problem is what? This one. Most of the people do the mistake taking 0. They always take everything 0, but not possible because there is a resistor in this particular context. In this particular context, there is a resistor. You cannot take like that. You need to find the voltage here, definitely. Then only you will come to know the current here. Then only you can find the current here. Then only you can find the voltage here. The sequence must be very clear. If you remember the sequence conceptually, you never do any mistake. If you try to by-heart it, you cannot solve any problem because networks are not unique. I'm telling you, there are infinite models you have. In exam, which network is going to be asked, we do not know. We cannot predict. So if you're thorough with the concepts, okay, then you can play with the networks. So that is why I stretch more on, the elaborated discussion I generally carry out in DC circuits, because if you are master in DC circuits, in my view, if you are master in DC circuits, you are master in entire networks. Entire network theory or master. Now, this is what about, the fundamental concepts before we step into the mesh analysis, node analysis. I think all of you finished this, right? And the second topic is what actually fundamentals of DC circuit is the first topic. Second topic is what actually here you can see methods of analysis, that is node analysis, mesh analysis. But before we step into that, let us look at certain problems on fundamentals which are being asked us several times in the GATE exam and IES exam and also some PSUs. Okay, so we'll look at them. Continuation with the classroom workbook 23 problem. Okay, so put the heading here, problems on fundamentals. Okay, more problems on fundamentals. So more problems on fundamentals. So far we have seen some problems on fundamentals, no doubt, but some more problems we'll see different varieties. Even we include certain GATE questions which were asked in previous papers. Okay. Start with 23 question number, classroom workbook question number. Determine the power supplied or absorbed by each element. Yes or no? So you have that problem with you. Please open that workbook. Classroom workbook. You can just refer the problem here. Find the power of each element, power supplied or absorbed by each element. Make an attempt, all of you. You can try first on your own. I'm going to explain you that. Meanwhile, I just take this complete off. Note down that problem and solve the problem. Find the power of each and every element. Okay, so look at this. The power P1, let us say this is P1, power of the element P2, this is P3, this is P4, let us say. Let us find one by one. P1, what is P1? Voltage into current. What is the current flowing here? 100 watt. The current is leaving from positive, therefore it is a supplied power. P2. To find P2, you must know current as well as voltage, but already current is known. How much it is? 5 ampere. What is the voltage across this? The potential difference across these two nodes we need to find. This is 20. If you take this one 0, this is going to be 8 volts. This is going to be 20 volts. Yes or no? Then what is the net potential difference here? Plus, minus. If I take 20 higher, 20 minus 8, then this will be plus. If I assume 20 greater, then this is plus. If I assume 8 greater, then this is plus. Yes or no? But I am taking 20 greater. 20 minus 8 is nothing but 12 volts. So 12 into 5. $60 watt. But what is this element doing here? What is the current doing here? Current is entering into positive. That means absorbed power. Okay. That is absorbed power. Look at this. P3. What is the current flowing here? Current here is 5 ampere. Here is how much? It is a current source, right? Depending on current, but current source 1 ampere. I value is already given here. Dependent source. I is a dependent variable upon which the source is depending. Okay, on. Now 1 ampere and 5 ampere, how much it is? 6 ampere. So 6 into 8, 48 watt. Current is entering. Absorbed power. P4. What is the voltage across this element? Both are parallel, therefore the same voltage will appear. 8 into 1, 8 watt. But what is the current doing here? Current is leaving from positive. It's not entering into positive. Remember, in the case of current source, you must be always careful. The current is leaving from positive. The tip is leaving from positive. Therefore, it is supplied power. Okay. Before you note down, just all of you look at this, and I will ask you some questions here. Just try to answer on your own, okay? Look at this. This element is absorbing how much power? 60 watt. Now, in the exam, he may ask you, what could be there in this particular box? Okay? Who is having the possibility to be in that particular box, like whether it's an active element or passive element? What could be this element? Is it an active element or passive element? Yes? 60 watt absorbed. Any passive element will absorb the power, we know that very well. But active element may also absorb the power, we already proven. In a multi-source network, some sources may supply, some sources may absorb, but at least one source has to supply the power in order to satisfy the telegen's law. Yes or no? But in this case, if you see in this case, now whether this element is active or passive, we cannot say anything because it is absorbed power. 60 watt absorbed power, what is that element? I can't say anything. It might be active or passive because passive element absorbs power. Active element may also absorb the power. Particularly in case of multi-source network, I cannot comment anything on that. I cannot say anything on that. But if I ask you, there is an element, okay, minus 60 watt absorbing. What do you say? Plus 60 watt supplying. Therefore, it is active element. Yes or no? There is an element which is actually minus 60 watt supply. That means plus 60 watt absorbed. Cannot say. Cannot say. It might be either active or passive. Yes, sir? There are two possibilities we have. You must be remembered. Sometimes he will ask you just tell whether it is an active element or passive element, whether it is an active element or passive element, active element or passive element. Second element is active element or passive element. So definitely you must find the power. After finding the power, you must comment. If that element is applying the power, positive value again, positive value. The value must be positive and it is applying the power, then you can say active element. If the value is positive and then absorbing the power, we cannot say anything. Okay, so please note down this quickly.